Thanks for the invitation, and it's a pleasure for me to speak about, let's say, the German, European, and of course, in a wider context, also international experience that I would like to share with you. And we talk about climate adaptive design, so I focused a bit in our work on how we think we have to respond to the crisis we are facing. I think we should speak about the crisis, and it's really important that we find solutions, and we have a lot of solutions. And let's go through this, and I also show you a few examples of realized projects that we have done. And Frank has introduced some of them, but I'm focusing more on really that projects that also give you an understanding or an idea what it really means to build, because I think we should always go beyond just, I mean, we're producing a lot of papers and master plans and things like this, but I think the real challenge is to get it into realization. And before that, the really real challenge is also to bring it into a, I would call it should be integrated in every project. And at the moment, we're still speaking a lot about pilot projects, but I think we have done enough pilot projects. We need to really bring it on the street in every project. So let's start. I'm very long. I'm about 26 years now in the studio Dreiseitl. Before it was Atelier Dreiseitl, and I think we have a long history in what is shown here. Really think integrated and holistic about how we can deal with water in the urban environment. I think that's really the basis of our work. And this means, so we have in each studio, we have landscape architects, we have some urban designers, and what is most important for us is that we do the urban hydrology with our own engineers. So we are not relying on external engineers because in my opinion, this is already a big separation. You have to start integrated, and this is why we as landscape architects, we have to have the knowledge about water systems. And in recent years, it has also become very apparent that also we have to have a lot of knowledge now about microclimate and how we deal with the heat problems in the summertime. So it's a lot about dealing with all these issues and finding also design processes that integrate all of these aspects. So Frank introduced us. So the Rambo Studio Dreiseitl core, I think it started here in south of Germany. We have a studio in Hamburg also, and in Copenhagen. And what is also quite important is that our studios in Asia, and especially in Singapore, because there we could test out a lot of our ideas in a much bigger scale. And this probably could be another lecture to talk about this project. So now let's focus a bit more on the European, and I will introduce you also the Queen's Botanical Garden in New York. So a little bit about our development, because I think this is also quite interesting, because as I mentioned, we have done many milestone projects, many pilot projects. So I think we are widely in the profession, we are widely known for these type of projects. Berlin Potsdamer Platz, 1998 finished. This was already about, you know, taking out a lot of stormwater from a combined sewer system and managing it in a densely urban site, because taking out stormwater from a sewage system means you protect the sewage treatment plant from an overflow, so that polluted water gets into rivers and it's harming the environment. Portland Tennis Springs Park is a lot about stormwater management, about reintegrating nature into an urban environment, and also that people have access to a nature in front of their doorstep. And we know after COVID how important it is to have nature close by and be directly exposed to it, because it's so important for our health. Copenhagen, I will speak about this. It's really a big holistic master plan about dealing with cloudburst events, so with a lot of rain in short period of time. And also the park in Singapore, you know, this little stream is meandering through this park and the whole park can be flooded. So this is really part of the design. And I will end also at the end of my presentation, I will speak about, we did some research projects, and out of this research project, we have developed a parametric design tool that helps to integrate all these aspects of blue-green infrastructure into this design based on their performance, and it helps to make early in projects clear decisions about, you know, what is the focus, what is needed in this project, what is the performance of certain measurements out of the blue-green infrastructure topic, and what is the best answer for this site. So when we talk about water, I think one of the most important things that needs to be understood is that everything is connected with everything. I think this is so super important to remind us every day when we work, that whenever we do something on one spot, it has an impact somewhere else, even if we have no idea what happens somewhere else. But whenever we pollute, we make surface impermeable, water flows up quickly, it has an impact somewhere else. And I think it's so important to remind us every day, so that we are, you know, in my opinion, also climate crisis is a relationship crisis. So we have lost the relationship to our environment, and if we have really a true relationship and understand that what we do has an impact somewhere else, then we are much more responsible, or we would be much more responsible. I think this shows very clearly what we have changed over the past 200, 300, 400 years. So a natural water cycle is really a lot based on evaporation, and most of the time also on infiltration, of course, depending on the soil, and very little runoff. Whereas in our urban environments, there is the relationship totally different. You see that red is much bigger, so we produce typically a lot of runoff. We have some evaporation and some infiltration, but we're really changing this natural water cycle dramatically, and this creates also a lot of our problems. So this is also quite important, a quite important message in my opinion, that we as landscape architects, you know, we very often seen as, yeah, it's not really nice to have landscape architecture, but you know, it's a soft, let's say, aspect of a project. But if we design around water, it's a real infrastructure. And we have to understand that in the past 200-300 years, we have very much designed our infrastructure based on very efficient technologies. It's very engineered. And so we really have to understand, if we deal with an infrastructure that we have to manage, for example, water, how we do it, how can we integrate it? How can we also find synergies of this water management? So in the previous year, the focus was much more on draining it out, getting rid of it, have no problem with it. And but now we have to think differently, because we have all these issues. We have sometimes too much water in short time, sometimes there's no water, then the dry periods. And then also what really affects us as humans, is these hot periods, because this really has a direct impact on our health. And that's why we can learn a lot from nature. And when you look at this image, you see all the measures, all the blue-green infrastructure topics that we need to deal with in our urban environments. So, for example, we have infiltration. The water is cleansed while it's infiltrating. So the soil and the water together creates the basis for plants to grow. It protects from erosion. Trees can grow. Trees produce oxygen. Trees are also produce biomass. They bind CO2, but they also, let's say, a living environment for biodiversity. So all these aspects, exactly these ones, we need in our cities. And so everything is there. We just need to translate it in the right way into our urban environments. And where we come from is we really also have to care about what we design. And this is what I meant also with infrastructure. How is our understanding of infrastructure? Is it just something we need to efficiently deal with, or is it something we can beautifully design? We can create livable spaces. We can use all the synergies that have to do with cooling, with creating a livable environment for us as humans, but also for a biodiverse environment. So there's a lot we can learn and we can integrate. So how can we do this? So very important is that when we design or when we think about, let's say in a bigger context, but also in a smaller project, when we think about where do we start with our designs, then the water system can be a super efficient tool to really come to very different design solutions. So think about, if the water system really is the basis, we understand the water system, we know how the natural water cycle of a certain area is. This always has to do with the relation between infiltration, evaporation, and runoff. And if this is the basis, the topography is very important. And when we have an understanding of this and how we manage water, so we don't really harm the natural resources or the natural system, then we start to think about how is the layout of the urban development over this? How do we place our buildings? How do we set our infrastructure and everything? But if the water system is the basis, and then we start to create this network through our cities. Because water is always a system, it is totally connected, everything. And if you also think about biodiversity, it's the same thing. It's a lot about connected systems. You always need, corridors where biodiverse areas can be connected. So the water system, and especially as it is an infrastructure need we have to deal with, and there's also money for it, and there is also, let's say, a lot of attention and a lot of engineering behind it, can be really a cool or a super element to deal with to come to different solutions. So when you think about a holistic water system, or about, let's call it, water sensitive strategies, then you should look mainly into these aspects. So we typically start with flood safety, for example. This is really a need that we have to understand and to integrate. So we talked there about Cloudburst corridors. I will explain you what I mean with this later. We really have to think in our urban environments about multifunctional use of spaces. So it's, the cities are densely built, so we have not enough space for dealing with water on the surface. This is why we have to use it multifunctional. And what is also super important, that we totally decentralize the stormwater management system. Whenever you create runoff, you create somewhere a big volume of water, and then you have a big problem to deal with. Whereas if you manage the water where it falls on the ground directly, you have much smaller problems and smaller issues, and you can also use the synergies. So flood safety important. Ecology and climate is more and more important. How can we protect the natural water cycle? I explained this. Let's start with water first, landscape second, urban development third. If we work in this sequence, we come to different solutions. And of course, the microclimate improvement is super important. We have these heat waves, and we have to deal with it. And water can be a solution. Water quality, of course, disconnect stormwater from underground systems. You know, the climate change mostly, or at least here in Europe, implies that we have more water in shorter period of times. Our current system are not really able to deal with this big volumes of water. So we really have to take out all the stormwater from any underground system and just have their sewage water. So we have we can much better control everything. And last but not least, you know, these aspects of the quality of green spaces, of biodiversity, multifunctional use, and so on. So all of these aspects you need to consider when you think about the water sensitive strategy. And it could look like this, you know, on the left side, you see a green space, a park areas, and when it's dry, you can play soccer or whatever. And when it's raining, it's flooded. So, you know, there's a time for everything. And this is what I mean with multifunctional, multi-purpose use. You have to wait for 2-3 hours, then the water is drained out, and the latest in the next day, you can play soccer again. Of course, this needs to be designed carefully, and of course, there's a lot of knowledge behind how you build this so that it's really working, but it's possible. Or on the image on the right side on the ground, you see it's just a filtration trench integrated, so the water runoff from the parking lot is going here. I mean, this is very simple. This is not high technology, and I think this is also used a lot. But how can this be integrated into a holistic system that you look at a big space in a way that there's no runoff, that you protect the natural water cycle, and maybe that you also create nature habitats with this water. So what we have learned is really that you know, starting with water first is, for example, a really good entry point is that we do this this Cloudburst risk analysis. So, you know, this is a huge issue. It's raining a lot. You have floodings in your city. How are you going to deal with this? And this is really, there's a high need in our cities. So we, for example, start really here with the risk analysis. What is the problem in my specific property? And I also have to look beyond my property, but what is the specific problem in my property and how can I deal with this? So this is always a good entry card. And then, of course, what we also do a lot with cities, for example, with the city of Singapore, they have, let's say, a way of how water sensitive planning shall be involved in each of their projects. And it's now so that there are really higher requirements for how with water has to be dealt in the project. So there should be very little runoff. The water should be cleansed. We should use a lot for evaporation. And you also have to have, let's say, you have to have integrated these big events, these catastrophic events. So, for example, up to the 50-year storm event or the 100-year storm event, you have to deal on your property with this, and you have to have. Then it creates again much less runoff and problems somewhere else. And then, of course, when we start our master planning in a small, big-scale projects, then we really also need to analyze the water system, and then based on this, we do this urban master planning. And a lot of discussions we have recently here is over how can we translate all of this into a legal plan, that it's binding, that it has to be done, that it has to be integrated. And this is really also related to how can we really make a big change. And if we have the legal requirements raised, then I think we can make a big change. And then, of course, it then goes into construction. So it's very important, yeah, that you start with the water from the very beginning of each project. So let's talk about different levels of projects. So Copenhagen Cloudburst strategy, like in many times, or like in many projects, when you have a big problem, then you need to find quickly solutions. So Copenhagen had a lot of floodings, and especially there was a big event in 2011. Within 2 hours, there fell really a lot of rain, and this rainfall created damages of 800 million euros. It's a really huge impact, big problem. And then here you can see the flooded areas in this event, and you can see that here around the train station or the St. Jürgen's lakes, you can see that big parts really of the old inner city center had been flooded. And we know that up to the year 2100, there will be 30 to 40% higher rain intensities in the rain events. So the problem will get bigger. And so what is the solution? So the idea that we came up with was that we wanted to create these so-called cloudburst corridors. You can see it a little bit here. The red lines are, let's say, the main road system, so they should be always working. You know, the emergency routes, they have to function. But in between, we have a lot of areas that we can use in these catastrophic events. So the water can, let's say, stay maybe for a certain period of time, even in a road. And let's think about a city that you have, you know, buildings there, and the water is flowing around the buildings. The buildings are safe and protected, but all the other areas, at least the ones that that are accessible, they can be used for a short term or a temporary storage of stormwater, and then it does not create a problem somewhere else, but it's just, let's say, contained in a safe space, and after a while it can be released. So the big strategy is also, although this is an old built city, the idea is that within the next 20 years, 30% of the storm water that goes at the moment into the storm sewer or into the sewage system has to be disconnected. And the last thing is that we also, you know, while investing on the surface and trying to rebuild the surface to build a topography that can deal with this big catastrophic flood events, we also can invest into the livability of a space. And we are not investing a lot of money in an underground system that is bigger and huge and can deal with more water. We are investing in a more dynamic system on the surface. And this was discussed widely also in the public, and the public accepted that that there is an investment. There's a lot of investment. It's around 1 billion euros in the next 20 to 30 years to rebuild a lot of the roads. And at the moment, you know, we have for the whole city a master plan. So for each road, we know how much water should flow through, what are the elevations, and whenever a road is rebuilt, this water layer has to be integrated. And with this, you create really a safer city, because in these really big flood events, you know, you can store a lot of water in the roads and totally decentralized. And you still can walk towards your buildings. You can enter the buildings. At least this is calculation for a 100-year storm event, flood event. But some of the roads are then used for storing water. And this is a totally different thinking. It's a dynamic thinking. It's a thinking of making use of space that we have that's maybe not needed when there is a heavy rain event, because there's less people out, there's less traffic, and so you can really use that space for the water. And when it's dry and safe, you can use it again for people and traffic and all the other purposes. And there's no need to build big underground volumes and storage pipes and whatever. You can really invest the money into the surface and integrate other uses that are needed. The same with the park. This is the park adjacent to these big lakes, and also this park can be flooded. Partly, you know, you have a safe corridor to get out, and the rest of the area can be flooded typically for a relatively short period of time, maybe 2 hours, 4 hours, and the water slowly can drain out. And with this, you can create a lot of safety for a city like Copenhagen. But of course, it takes a long time. So this is really the task of a generation to rebuild the city in that way. And just to give an example how the effects of integrating these water sensitive aspects into a design. So this is just, for example, a 55-hectare typical area in Copenhagen. So the 5-year storm event creates, let's say, something like 17,000 liter of runoff from this area. So, for example, if you would have on all the buildings 10 centimeter green roofs, you can reduce the outflow for almost 20%. And if you use this concept of cloudburst streets, of course, of permeable surfaces, of green spaces, of bioswales, of retention areas, if you create all of this, and we tested this for one area, you can reduce the outflow 45%. And this is huge. This is a huge volume that you keep in the city, and it can infiltrate, it can evaporate, it can be used for reuse purposes, and so on. So the effect is really big. And if we would build cities already like this, we would not create so much problems. So then let's talk about a few projects. Other projects, build projects. I start with just one building plot. Then I show you a bit bigger plots, then a housing development, and also the Queen's Botanical Garden. And just to explain you how this is integrated. So this is a project, Kampung Admiralty in Singapore. You see the plot is completely built over, and the wish was, of course, to have a really green environment, a really green surface. Although it's a new development. Kampung, by the way, means village. So the whole building functions like a village. So there's a lot of uses there. So you have a car park, you have a retail and food shop. You have a food center, the so-called hawker centers. You have a medical center. There's an area for aging people. There's a childcare center, and there's some public spaces, and of course there are some apartments also. You see, it functions like a little village, and the center is really this green space. And from a water point of view, so this whole system is built like as if there would not be a building. So the design really does not impact let's say, the natural water balance, although we build completely over it. And this is done by, all the green roofs you collect, water can stand there, can evaporate. We used it also, to change the appearance of the building. So for example, here are some little waterfalls. When it's raining, water falls from one level to the next level. So you really use it as a design feature also. And here's a rain garden, water can stand there. You have a storage tank. We reuse it for toilet flushing, also for irrigation purposes. And only if this whole system is completely full and the water drains out, we have here a cleansing biotope there before it enters then out. And this is just for emergency cases. So you can build a building over an area and you are not damaging or harming the natural water cycle. So this is possible, and I think we need to go that road. It's really an urgency also to think in this direction. And when there is no rain, or let's say when there is rain, in Singapore there is a lot of rain. This plaza is also a protected plaza that's open for the people, and this is then the space for the people. And there's other space that's for water and nature. Okay, now let's look into a plot scale, a little bit of bigger scale. This is the campus of Alnatura. Alnatura is a supermarket chain here in Europe, especially in Germany. You see here the plot. It's a former US Army base. You see a lot of concrete surface here. This is then the new building. So, for example, we left the concrete in where we have the parking lots. This is the new building. You see here the protected forest, and here you have, let's call it a biodiversity area, a kindergarten, and so on. And this is the space how it is built. And you can see this new building. It's, by the way, it's a clay building. It's built of clay. So, and here you can see the kindergarten. Here you can see a big urban gardening area. And here on the right side, you see this biotope area. Here, by the way, that's inside of the building, a really nice building. You look out into the landscape. And when we look into the water system, then we have something like, let's call it a stormwater cycle. So we are using, for example, this biodiversity area to have some water stored there, this retention volume, this bioswales here. The water has time to infiltrate. The same here. Whenever there's water raining from the parking lot, so we collect it in these ditches and also around the kindergarten. And then we have a big cistern. And with all these measurements, there's no connection to the sewer system. So all the water in every case, also the 100-year storm event, the big storm events, this is all managed on site. And we have built this huge cistern. It's an 800 cubic meter cistern, so it's really big. And we collect the water from the roof, and we use it for, as I mentioned, for toilet flushing, but also for irrigation of this big urban gardening area. And for example, you know, so we are infiltrating and evaporating 30,000 cubic meter per year, which is 72% of all the rain that falls on the site. And the rest, of course, there's some overflow and some runoff. And with our 800 cubic meter system, we save approximately 12,000 cubic meter of tap water that would be needed here to do the irrigation and the toilet flushing. And of course, this is a huge investment on one hand. On the other hand, it's also a huge saving of precious tap water. And here you can see this is for the people that work there, but also for adjacent neighbors, so they can grow their vegetables and fruits and use the rainwater to grow this. And we have also used, for example, a lot of the concrete that has been crushed in a certain way that we can reuse it. So we have not transported this big concrete volume offsite. We have used it and integrated. This is also about, let's call it a material cycle, you know, that you're not just throw everything away, but you also think about how you can reuse it. Okay, actually, the Queen's Botanical Garden, I think, goes in the same direction. It was a big master plan for the whole Queen's Botanical Garden, and especially in this area here, this new administrative building has been built. It's LEED Platinum certified, by the way, and we have integrated here already also a really holistic water cycle. And maybe if you have time, you really can go by there. It's about 8 to 10 years old now, the project. And what you can see here is really also the water is part of the design. The water is really like a channel going through. Nature's going up the green roof, so you can walk up the green roof. And with the stormwater, for example, we also managing up to the 100-year storm event completely on site. So we are, you can see here that all the drainage is going towards this channel. We have a huge cistern also. We collect a lot of the roof water in the cistern. And then we have here a bigger retention and bioswale. And with this, we are able to manage almost all the stormwater on site. And you see this biotope here. We have a cleansing circulation. There's a constructed wetland that is responsible for cleansing this all the water in the water system. And there's also permanent circulation. This is the source where the water comes out, then it flows down this channel. You can see here how the landscape is really moving up into the building. And this area here is the constructed wetland. And this constructed wetland, we are collecting the gray water out of the building. And the gray water is the polluted water that has no contact with toilets. It's from sinks and from showers and things like this. And we treat it in a constructed wetland, and we also use it, store it, and we also use it for toilet flushing, irrigation, machinery washing, and so on. We really try to find a holistic, closed water cycle, not only for the stormwater, but also for the water that's used in the building. Here's some images how this is going through. Also the roof, this protected plaza, and the roof just drops down and falls also into the system. So this is for us quite important that we also tell the story, explain how we design with water and how we integrate it. Okay, then let's go to a housing event. And this is also a very typical image for us, because this is what we call water infrastructure, or let's call it beautiful water infrastructure, because this is also a retention volume. So it has a function within this stormwater system, but it also creates a beautiful environment for the people that live there. So this is a super ecological development, not big. It's about 4 to 5 hectares. I don't know how many acres. But it's not huge, but it's very special and very densely. And what you can see here, you know, the photo was made from standing here, and you're looking up. This is the lake, and you can see that we have the lake is part of the stormwater system. Here is water stored. We collect all the water on the surface, on the roads. These are the little runnel that directs the water towards the retention volumes. In green, you can see the retention volumes. And in the center, we have the lake. And at the edges, we have this more bioswales. And when the whole system is full, then it can slowly be drained out into these adjacent little stream and river. But this means you really have to have all the water on the surface. You know, we have to, if you have, for example, a downspout that is inside the building, which is very often the case in newer buildings, you have already a problem because the water is then lost. Then you have to have only the chance to connect it to a sewage system. But if it's on the surface, you can let it drain here, it drops down the road, then there is a little runnel. And of course, you also have to make permeable surface wherever possible, to at least to make sure that not a lot of runoff is created. And this, let's call it beautiful infrastructure, is also let's say a biodiverse. It's a living space. It's a habitat also for flora and fauna. And this is when you remember the start of my presentation, I said we have to learn a lot from nature. How can we bring all these aspects of this meadow into our urban environments? And this is possible. We can live together. We can live in a dynamic relationship with water and with biodiversity. And this is what we need also really everywhere. And you know, this is very simple. You know, it's just a depression, and the water can stand there for 2-3 hours. Of course, you have to do the calculations. And also the emergency overflow, it's not really built. It's just, you know, it's just happening because here it's the lowest spot of everything. And this is how it should be designed, in my opinion. And when there is cloudburst event, big events, big storm events, then it's visible in this development, and the runnels are full of water. A lot of water is draining down. And again, here, this is the center of this development. This is the green center, a playground also, a place where people can gather and sit and have their evening beer. But when it's raining, this part is flooded. Yeah. And this is again this dynamic situation. And you can see here in this image that it's really designed for exactly that purpose. This is a reduction element so that the water cannot really flow out. So we hold it back. It can stay there. It does not create a problem somewhere else. It's maintained in this development. This new development, we are responsible for this development. We are responsible for the water system. We are responsible that we're not creating a lot of runoff that's creating a problem somewhere else. So we have the solution here on the side, and it's a dynamic place. And when it's raining, then it's space for water, and when it's dry, it's space for people. So this gives you an idea about the projects. And now I wanted to touch at the end also a little bit about the planning process, because I think the planning process is quite important, because very often we have a very silo process. We start with maybe, I don't know, urban design, infrastructure needs to be designed, the water system has to be solved. There's so many aspects that need to be solved, and typically this goes not really together. This goes most of the time in separated roads and silos. But we have to come to a design process where everything we design has to have purpose with respect to microclimate improvement, to all the water aspects like collecting water, dealing with too much water, evaporation, creating enough water, having water also that it can be a green spot, and so on. All these aspects that we need to improve all these climate issues that we are facing has to have a function. So this means, and if it's just an existing school courtyard, this is, for example, a project that we are doing at the moment in Cologne. So we're just looking at every spot, what can we do to improve this and to deal with water in the urban environment different. And in the beginning, I have showed you that we have been also working in research projects. And an outcome of this research project was that we have a lot of information about the performance of aspects of these blue-green infrastructure measurements. So, for example, a tree, you can, let's say, define to a certain extent, not super precisely, but to a certain extent, you can define the performance of a tree. A tree can evaporate a certain volume of water, can create so and so much oxygen, can collect some dust, and so on. It reduces the temperature below, on the surface below it. And so this performance calculation for many other aspects like infiltration swale, for a green roof with 20 centimeter build up or a green roof with 50 centimeter build up, you can have a lot of performance around heat and water management. And all of this we, let's say, put together into this digital parametric design tool, or we call it Green Scenario. And this is this is a tool that looks on green, also how much green and what is the quality of the green, about the water system, the microclimate aspects, and what these measures that we use are costing. And with this, we try to inform the design process early on in in design processes. So it's a tool that we use in early phases in the master planning and concept design of projects. It's for small areas like 1 hectare up to 200 hectares. So it can be used for different scales. And just to explain you a bit how it is working. So for example, you have here this area. Let's say it's a 15 hectare urban development. You have the building layout. And then we put in all these measures that we have seen before, these water management levels. And then you can see the performance. For example, our aim is to protect the natural water balance. And the natural water balance for a specific site means the relation between evaporation, infiltration, and runoff. And now we are building over it. And for example, with these measurements that we have here, some green spaces, some biospheres, some trees, and so on, we have the natural water balance achieved for about 50%. And then we can go one step further and, for example, say, okay, now let's put on 50% of the buildings a green roof. And you can see that the natural water balance, we have now achieved it for 55%. So we really see whenever we put a blue-green infrastructure topic into this development, place it, then the performance that we know from the research project then is showing the impact and how close we are to a certain benchmark that we want to achieve. And this is, of course, super helpful in very early projects, so that you are not designing, this is, I do this and that, and then I know it's a green project. But here we can really see how green it is and how sustainable it is and how close you are to, for example, biodiversity goals or to stormwater quality, and also to the microclimate aspects. So we do like a wind analysis, for example, and we really design with microclimate modeling tools. This is more and more common. And then you can, of course, do a lot of different scenarios. Yeah, for example, you can put in more measurements that's more dealing with water management, or the heat aspect is more important. And you put in these topics into your design, and then you know the performance, and then you can make a decision also based on performance that you achieved and also costs that you are producing with these measurements. So I think this is really what we need. This is informed design, informed climate adaptive design, and not something we think this is good, but we don't really know the performance. And I think this is the future we need to go. Yeah, we have done enough pilot projects. We have done enough projects that show how different measurements are working. We have the knowledge. Now we have to adapt it, and we have to use it and adapt it in every project that we do. No excuse. So that's what I wanted to tell you. Thank you very much.